Lesson 2-2 is on linear relations and functions. A linear relation is a relation whose graph is a straight line. Notice I didn't say it's a linear function because the one linear relation that we're aware of, that we learned in the last lesson, is that of a vertical line. A vertical line is a straight line, but it is not a function because it fails the vertical line test. If you're looking at an equation, a way to tell whether or not it is linear is if it has only addition, subtraction, and multiplication of a variable by a constant. If it has no variables multiplied together, if it has no variables in the denominator, and it has no variables with exponents greater than 1. A linear function can be written in the form f of x equals mx plus b, and you'll recognize that as y equals mx plus b, where m is the slope, b is the y-intercept, and both m and b are real numbers. So let's take a look at some examples here and determine whether each function is linear and explain, especially if it's not linear, why is it not linear. Number 1, f of x equals 5 divided by x plus 6. This is not linear because we have the variable x in the denominator. Okay. Number 2, g of x, and remember g of x is just another name for a function besides f of x. G of x equals negative 7 plus 1/4 x. Yes, this is linear, because actually this is in the form y equals mx plus b. It could be written as y equals 1/4 x minus 7. So that is the equation of a straight line. And number 3, h of x equals the square root of x plus 1. And this is not linear because a square root is actually the same thing as having an exponent of 1/2. So, and if you were to graph that on your calculator, you would get something that looks like this. It's kind of like a sideways, half of a sideways parabola. Standard form of a linear equation, you'll probably remember this from Algebra 1 as well, is ax plus by equals c, where a, b, and c are integers. They cannot be fractions or decimals, and they have a greatest common factor of 1. In other words, a, b, and c cannot all be divided by the same number. A has to be positive, and both b and a cannot be 0. One or the other can be 0, but not both of them. Let's take a look at a couple examples here. Write each equation in standard form, and then identify a, b, and c. First step is I want to get x and y on the same side of the equal sign. So I'll subtract 9x from both sides, and that leaves me with a negative 9x plus 3y equals negative 12. And I'm noticing that 9, 3, and 12 are all divisible by 3, and my a is a negative number. Your first term has to be a positive number. So I'm going to divide everything by a negative 3. And when I do that, I have 3x minus y equals 4. That's in standard form. A is 3, b is negative 1, that's the coefficient of y, and c is 4. Here's another example. 2/3 y minus 3/4 x plus 1/6 equals 0. First thing I would like to do is try to get rid of those fractions. So I'm going to multiply by the common denominator, which is 12. So I'm going to take the whole equation and multiply it by 12, or 12 over 1. What this will do is get rid of my fractions for me. 2/3 times 12 gives me 8y. 3/4 times 12 gives me 9x. And 1/6 times 12 gives me 2. Okay. So I'm pretty close here, but I need to move that 2 to the other side. So I think I'll go ahead and do that. And I'm going to switch my x and my y, because my x needs to come first, followed by my y. So negative 9x plus 8y equals negative 2. And remember, a has to be a positive number, so I'll just divide everything by negative 1. And I have 9x minus 8y equals a positive 2. A is 9. B is negative 8. And C is 2. Recall also from Algebra 1, x and y intercepts. The x-intercept is the x-coordinate of the point where the graph crosses the x-axis. And that's going to be some number a, comma 0. And the y-intercept is the y-coordinate of the point where the graph crosses the y-axis. And that's going to be 0, comma some number. Notice that for the x-intercept, y is always equal to 0. And for the y-intercept, x is always equal to 0. So here are a couple examples. We need to find the x and y intercepts and then use those intercepts to graph. So for the first one, I'm going to find the x-intercept. So I'm going to let y equal 0. So negative 9x minus 7 times 0 equals a negative 30. And negative 7 times 0 will cancel out. I have negative 9x equals negative 30. So x is equal to 10 over 3. But since I have to graph this, I'm going to turn it into a mixed number, or 3 1/3. Let's find the y-intercept. To do that, I will let x equal 0. And then I have negative 9 times 0 minus 7y equals negative 30. The 0 cancels out there. Negative 7y equals negative 30, and I have y equals 30 over 7, which turns into the mixed number of 4 2/7. So my x-intercept is 3 1/3. My y-intercept is 4 2/7. There's one part of my answer. Now the second part is to use those to graph. So my x-intercept is where the graph is going to cross the x-axis, and 3 1/3 is right about there, a little bit more than 3. Y-intercept where it crosses the y-axis, and 4 2/7 is about there. And we just connect that. And there's our line. Here's another example that involves fractions. And in this case, I don't necessarily want to clear those fractions. I can actually, it's not going to be that hard. So to find the x-intercept, let y equal 0. So that's going to be 3/4 times 0 minus 2/3 x equals 12. Or a negative 2/3 x equals 12. To solve that for x, multiply by the reciprocal. Negative 3 over 2. And that will leave me with x equals a negative 18. To find my y-intercept, I'm going to let x equal 0. So 3/4 y minus 2/3 times 0 equals 12. Or 3/4 y equals 12. Again, multiply by the reciprocal. And y equals 16. So my x-intercept is negative 18. My y-intercept is 16. And to graph those, my graph isn't quite big enough, so I'm going to actually count by 2's. And if you do that on a graph, be sure you note that and tell me that. X-intercept of negative 18 is going to be right there. Y-intercept of 16 is right there. And my graph looks like that.